Hello students, welcome to lecture 1 of atomic structure. Introduction of atomic structure. The word atom derived from the Greek word atomio. Atomio means uncuttable, or non-divisible, So we cannot divide that atom. It is a ultimate particle, and the atomic theory of matter first proposed by John Dalton, and he is a British school teacher, and his theory called Dalton's atomic theory. Dalton's atomic theory. And according to his theory, the atom considered as ultimate particle of matter. So the atom is a ultimate particle of a matter. And end of the 19th century, atoms can be further divided into subatomic particles. Let us discuss that subatomic particles. Atoms further divide into subatomic particles. That subatomic particles are electrons, protons, and neutrons. First of all, we are going to discuss about electrons. Discover of electrons. Let us discuss the discover of electrons. So here it is this is the cathode ray discharge tube. In 1850, Michael Faraday studied the electrical discharge in cathode ray discharge tube, and this tube is made up of glass and containing two metal electrodes. So this side we have cathode electrode, and it is a negative electrode, so there is a negative sign. And this side we have anode electrode, and this anode electrode is a positive electrode. And in this tube we have gas particles, and here also we have vacuum pump. And anode side we have fluorescent coating, it made by zinc sulfide, and here we are applying high voltage. So in 1850, Michael Faraday studied the electrical discharge in cathode ray discharge tube, and this tube made up of glass, and it contained two metal electrodes, cathode electrode and anode electrode. And this gas absorbed in the tube at high voltage and low pressure. When we apply the high voltage, the current start flowing through a steam particles from negative electrode to positive electrode, means from cathode to anode. And these rays are called cathode rays or cathode ray particles, and they are flow from cathode to anode. And pass through the holes of the anode. So there are holes at the anode, and that rays pass through the holes of the anode. Then the rays strike on the zinc sulfide coating, and the bright spot on the coating is observed. So here the properties. Number 1, the cathode rays start from cathode and moves towards the anode. So the cathode rays start from cathode and moves towards the anode, and these rays themselves are not visible, but they can glow when they hit the fluorescent or phosphorescent materials. When these rays are hit the fluorescent or phosphorescent materials, then they can glow. So here the rays, they can glow when they hit the fluorescent or phosphorescent materials, and in the absence of electrical or magnetic field, these rays travel in a straight line. These rays are travel in a straight line in the absence of electrical field or magnetic field, and in the presence of electrical field or magnetic field, the behavior of cathode rays is similar to that of negatively charged particles, and it is suggested that the cathode rays consist of negatively charged particles called electrons. So in the presence of electrical field or magnetic field, the behavior of cathode rays is similar to that of negatively charged particles. It is suggesting that the cathode rays consist of negatively charged particles called electrons, and the characteristics of cathode rays do not depend upon material of electrodes. And nature of gas. Thus, we can conclude that electrons are basic constituents of all the atoms. That electrons are basic constituents of all the atoms. The characteristics of cathode rays do not depend upon the material of electrodes and nature of gas. Thus, we can conclude that electrons are basic constituents of all the atoms. And the well-known thing is television. We know that television picture tubes are cathode rays tubes, and television pictures result due to the fluorescent or phosphorescent materials. So these cathode rays are negatively charged particles called electrons. So this is about discovery of electrons. Next one, charge and mass ratio of electron. Let me take one diagram. So this is the diagram for measure the charge and mass ratio of electron. So here this is the cathode, negative sign, and this is the anode and positive sign. And here we are taking the electric field and magnetic field. So these two fields are perpendicular to each other. So here the electric field will be like this and the magnetic field will be like this. So these two are perpendicular to each other. So in electric field, so this is the positive sign and this is the negative sign. And in magnetic field, this is the north pole and this one is the south pole. So these two are perpendicular to each other. And this one is the fluorescent screen. And there are 3 points, A point, B point and C point. And the cathode rays means that electrons start from cathode and hit the fluorescent screen at different 3 places with different conditions. In 1897, J. Thomson measured the ratio of electric charge represented by E and mass of the electron represented by Me by using cathode ray tube and by applying electrical and magnetic field which are perpendicular to each other to the path of electrons. So here we are applying the electric and magnetic fields to the path of electrons. So see here, this is the electric field and this one is the magnetic field and this is the electron path. So here we are applying electric field and magnetic field to the path of electrons. And he observed that the amount of particles deviate from their path in the presence of electric field and magnetic field. When only electric field is applied, the electrons deviate from their path and hit the fluorescent screen at point A. So here we are applying only electric field. So in the presence of electric field, the electrons deviate from their path and hit the fluorescent screen at point A. Similarly, when only magnetic field is applied, electrons deviate from their path and hit the fluorescent screen at point C. And when both electric field and magnetic fields are applied simultaneously with the same strength, thus the electron bring back to its original path, as in the absence of electric field and magnetic field. So here, in the presence of electric field, the electron path deviate and hit the fluorescent screen at point A, and only in the presence of magnetic field, the electron path deviate and hit the fluorescent screen at point C. And in the absence of both fields, electron hit the fluorescent screen at point B. There is no deviation in the path of electrons. In the same way, both electric and magnetic fields are applied simultaneously. Electron hit the fluorescent screen at point B, same as that in the absence of electric and magnetic field. So here the J. Thomson determined the value of E by Me, charge by mass of electron. that is equal to 1.758820 into 10 to the power of 11 coulomb per kg. So here E is the magnitude of electron charge in coulombs and Me is the mass of electron in kg. So E is the magnitude of electron charge in coulomb and Me is the mass of electron in kg. And here charge of electron by oil drop experiment, Millikan determined the charge on electron as minus 1.6022 into 10 to the power of minus 19 coulombs, and the mass of electron determined by Me is equal to charge of electron divided by ratio of charge and mass of electron, E by Me, is equal to the charge is 1.6022 into 10 to the power of minus 19 coulombs divided by charge and mass ratio of electron is 1.758820 into 10 to the power of 11 coulomb per kg. Then we will get Me is equal to 9.1094 into 10 to the power of minus 31 kg. So this is about charge and mass ratio of electron. Next, deviation of particles depends on magnitude. So here, greater the interaction with electric or magnetic field, greater the deflection. Greater the interaction with electric and magnetic field, greater the deflection. And mass, lighter the particle, greater the deflection. Lighter the particle, greater the deflection. And strength. Here, deflection of electrons increases with increase in the voltage. Deflection of electrons increases with increase in voltage or with increase in strength of magnetic field. With increase in strength of magnetic field. So the deviation of particles depends on magnitude and mass and strength. So this is about discovery of electrons and charge and mass ratio of electron.